Okay, let me welcome you all to ANA 203. In this session, we are going to cover BigQuery DataFrames and how BigQuery DataFrames makes it easy and efficient when working with large data and training model while working in your favorite Python APIs. I am Sandeep Karmarkar, product lead with Google BigQuery. And with me, I also have my colleague, Sonakshi. We are also thrilled to be joined by a guest speaker, Guillaume, who joins us from one of our esteemed customers, Carrefour. Together, we are going to cover these 4 key topics. We'll tell you a little bit about what got us to building BigQuery DataFrame. What problem is it solving? Then we'll tell you a little bit more about what BigQuery DataFrames is and what value does it bring to the table. Then Sonakshi will take us on a journey from data to model to LLM, all through BigQuery DataFrames in a live demo. Fingers crossed. And lastly, Guillaume will come on stage and tell us a bit about Carrefour and how 2 teams in Carrefour from 2 different continents found value in BigQuery DataFrames. So let's get started. Let's get started, as always, with the big picture. We all know generative AI is transforming the IT landscape. At Google Cloud, we have the most comprehensive platform to harness the value of generative AI. But we also believe to harness the value of generative AI, you need to bring AI to your data. Bringing AI to your data breaks down the barriers and helps you reducing time to insights, time to value with these new exciting technologies. And that's why our flagship warehouse, Google BigQuery, is evolving into a unified platform with a set of capabilities that makes it a one-stop shop for AI data platform. Now, this platform is designed to work across different data practitioners, be it data engineers or ML engineers who are responsible for building data pipelines, ML pipelines, or be it data scientists who train, evaluate, and manage machine learning models. Or it could be data developers who are responsible and who will build solutions on top of our data platform. This platform is designed to work across all of them. Now, here is an interesting question about these data practitioners. We all know they use SQL when working with data. But when it comes to a programming language, what do you think is their most preferred favorite programming language when working with data? Any guesses? All right, unison. Yes, it is Python. As we would call, data practitioners are Pythonic. And Python has been rising in popularity for last many years. Be it data wrangling, be it data analysis, be it data visualization, training models, making features, all of that, data practitioners prefer Python, and that's great. However, when it comes to working with large data sets and working with training or transformations that require significant compute, they typically face challenges. And to explain that, let's look at a typical Python data workflow. Yeah? Let's imagine we want to analyze certain data, or we want to train certain models. And we know what data we want to work on, and we want to work in Python. All right. So we get started typically by creating a notebook. Yeah? We attach this notebook to certain runtime that gives us the required resources. And then we download some of our favorite packages, starting with Pandas. And then we connect Pandas to our favorite data warehouse, which of course is BigQuery. So we are all set up now. We are ready to work with Pandas. So now we'll create our Pandas data frames. We create our Pandas series. And the first thing Pandas does is going to copy your data from your warehouse to your memory. But once it's in the memory, you have all the Pandas goodness, all those APIs to wrangle data, clean data, join data, merge data. You can further go ahead and download packages like scikit-learn and go into machine learning. You can train your models. You can do feature engineering. You can build pipelines. All of this is happening in your local compute, in your local memory. And at the end of it, you hope to arrive at the answer that you are looking for. This works. This works if the data set is small. This works if the compute requirements are small. But as the enterprise users, that's hardly the case. We frequently have to deal with terabytes of data and transformations and large joins that hardly fit in our local CPU. So as the data practitioner, you're now either limited by the data that you can fit in your memory, or the compute that you have. But interestingly, it also throws in some governance challenges. When data is getting copied around, it definitely raises some governance eyebrows. But you also have to understand, as the data gets transformed locally in your notebooks as an example, and then you materialize it at the end of it, nobody is automatically tracking lineage for you. So if someone asks, where did that table come from? Where did those features come from? You do not have an easy way to answer. So as a data practitioner, now you have a choice to accept these restrictions, maybe work around them, right? Maybe start doing sampling, maybe doing things that fit in your local CPU, or beg, borrow, steal larger VMs from somewhere. Or some of the practitioners choose to adopt a different technology. So now maybe you have to start learning Spark. Maybe you have to start learning Ray or Dask or other technologies. But not everybody wants to do that. And not everybody can do that. Very frequently, we hear our BigQuery Python users telling us that, I wish there was a way that we can keep working in our Python environment and BigQuery can magically take care of compute and resources for us. And that's why we launched BigQuery DataFrames. BigQuery DataFrames is an open source package, open source Python package from Google that supercharges your Python data APIs by leveraging the distributed computing power of BigQuery. It does so by translating the common APIs from Pandas or scikit-learn into BigQuery SQL or BigQuery ML SQL and pushing it down to BigQuery for optimal processing. So it provides you the server-side processing capabilities for your common Pandas APIs. So now, neither you are restricted by your local compute or your local data, and nor you have to choose to switch to a different technology just to make it work. BigQuery DataFrames makes it work for you. And today, we are announcing general availability of BigQuery DataFrames. Going into more deeper, BigQuery DataFrames really excels in 3 key things. It does optimal and transparent execution of your common Python APIs in a most governed and secure way. So when it comes to execution, BigQuery DataFrames adopts a lazy or a deferred execution approach. So when it does transparent translation of your APIs, it is building this SQL behind the scene on the client side until the data is actually required. And that's when it will push down these queries down to BigQuery so that BigQuery's query planner can optimally execute these APIs for you. BigQuery DataFrames also provides you intelligent data indexing so that the data in a data frame, the same data in a data frame, can be accessed in the same order every time. Data is never copied in memory, so this indexing is a non-trivial achievement. Secondly, when it comes to APIs, you will find most of your common Pandas and scikit-learn APIs already implemented, and the list keeps growing. And lastly, as I mentioned, data is never copied into your local environment. So all these Pandas data frames or series that you're working with within BigQuery DataFrames, those are actually virtual objects backed by BigQuery's tables, permanent or temporary tables. And this data is always accessed using your end user credentials. So now you get the most secure and governed experience behind the Pandas API that you like the most, while taking the benefit of BigQuery's serverless scalable processing. Let's dive deeper. BigQuery DataFrames is really a Python package made up of two libraries, starting with BigFrames, which stands for BigQuery DataFrames, bigframes.pandas. This is where you will find most of your Pandas APIs implemented with transparent and optimal translation and pushing it down to BigQuery. Whether it is aggregating, whether it is joining, whether it is cleaning, we have all those APIs implemented as transparent execution. We also give you APIs to load and store data from sources other than BigQuery, be it GCS, or it could be your local environment where you have your CSV files. We allow you to do that as well. In some cases, you want to go from your local Pandas data frames to BigQuery data frames. We also offer you that round trip, as we call it. Secondly, we also realize that working with data often requires data visualization. And that's another challenge when you're working with large data sizes. So natively, we have also made certain visualizations available on top of our BigQuery data frames, be it histograms, be it scatter plots. And we're actually going to demo that in our demo today. And lastly, our server-side processing is not just limited to the APIs that we have implemented. Very often, we find our customers wanting to use their custom business logic on the data frame, wanting to apply that on a data frame, but not wanting to copy that data again in memory. And you can do that with BigQuery DataFrames as well. All you have to do is add a Python decorator on your Python function, and we will automatically create a BigQuery remote function for you and deploy it and execute it when it comes time to executing that function. So now your data, even for your custom execution, stays within BigQuery, stays on the server side. So you can now have your custom business logic along with our APIs, all powered by server-side data processing with zero data copy, and again, with the governance that we offer. The second library, equally important, is on the ML side. This is where we offer BigQuery.ml, BigFrames.ml, and this implements the scikit-learn APIs. So all of your common scikit-learn APIs are transformed into BigQuery ML SQL calls. BigQuery ML, for those you don't know, is BigQuery's scalable server-side, serverless machine learning platform. And so it offers you, through these APIs, capabilities for creating features, whether it is encoding, whether it is scaling. You can now start to train your favorite models, whether these are ensemble models, whether these are regression models, whether these are linear models. And you can also build scikit-learn pipelines. So now you can build a transform and training all together, just as you do in scikit-learn. And again, behind the scene, we'll take care of converting this into BigQuery ML and pushing it down to BigQuery for server-side data processing. And if you like it so far, let me add a cherry on top. No discussion is complete without an LLM angle, right? So here as well, in our bigframes.ml, we have added a subpackage, bigframes.ml.llm. And this is where we make our latest Gemini, as well as Palm 2 endpoints available to you within the same Python notebook, the same data frames objects that are available in BigQuery DataFrames. So now you can start doing your text generation and text summarization right within your notebooks. But the best part about this is you can use data frames as an input, creating your prompts and output to get your responses while working with this Gemini APIs. So how do you use this? It's a Python package. All you have to do is pip install, right? But we have also made it further simpler. BigQuery announced BigQuery Studio notebooks in general availability today. And our BigFrames Python package comes pre-installed within notebooks. The latest package is always pre-installed. So now you have an end-to-end solution, whether it is your DataFrames package or your notebook offered together within BigQuery Studio environment. And this is something only BigQuery can offer. But we also work closely with some of our partners. And whether these are notebook partners, whether these are visualization partners, they have listed here so that you can get started with other notebooks and other visualizations equally easily with BigQuery DataFrames. If this is interesting to you so far, let's look at it live. Let me invite Sonakshi to take us through the journey. Sonakshi, the stage is yours.
Okay, so for the purpose of this demo, I want you all to imagine that you are creative strategists, okay? And what you want to do is you want to use your customers' shopping data. You want to use this data to create personalized marketing emails for your customers. You are all creative strategists who love using Python and who love Pandas and scikit-learn and love using BigQuery as well. So in this demo, what we are going to do is you are seeing two tables on the left-hand side, users and order items. We are going to use these two tables to do three things. First, we will load the data from this table, filter the data and load it into a data frame. Second, we will build a pre-processing set, a feature set, and we will use that feature set to train a k-means model. This k-means model will allow us to create different groups of customers based on their shopping habits. And number three, we will use our Gemini LLM model to understand the results of the k-means model and use that to create personalized marketing emails. So these are the three things we will be seeing in the demo. And all these three things will be powered by the two libraries Sandeep mentioned earlier, BigFrames Pandas and BigFrames ML, okay? With that, let's dive into the console. Okay, perfect. So this is my BigQuery console here. I want to begin by showing you the two tables that I spoke about earlier. So this is users table. It is a fact table that contains all the information about the users. Here, ID is the primary key. And other than that, we have first name, last name, address, and other information. The second table is order items table. This is a dimensions table. So this contains the user ID, which we will be using for joining the two tables. And it contains other information about the orders like create date, what is the status, and other things. For the purpose of this demo, Sandeep mentioned that BigQuery Studio supports notebooks. So we are going to use this notebook in order to run our demo. The biggest advantage of using BigQuery Studio notebooks is that you can run your data analytics and machine learning operations right into the BigQuery console without having to leave it at all. And before we get started, I want to point out that my notebook has a runtime connected to it. My runtime has 15 gigabytes of memory, just 15 gigabytes of memory, and it has 4 vCPUs. And one thing that I did not mention earlier is our order items table. It has 1.7 terabytes of information. So using our simple notebook, we will process up to 2 terabytes of information that is there in our tables. So with that, let's jump into the fun part. So this is the notebook. I've already pre-installed some notebook variables and I've set up the BigQuery session so that we can all focus on the fun part. So first, here in this step, what we are doing is we are reading the data from the order items and the users table. Then we are using the merge function to join the two tables on the user ID field. We are choosing only the required columns and we are dropping duplicates. So you will notice that I have imported BigFrames Pandas package here. I'm using read gbq table function to read the data from BigQuery table. I'm using the merge function. And if you have been a Pandas developer before, you will notice that this is the exact same syntax as Pandas that we are using to load the data into BigFrames and to choose required columns and drop any duplicate values. So when I ran this, you notice that a query job was triggered and a query job is running. Let's click on it and let's look what happens. So I want to take you back to the point where Sandeep mentioned that BigFrames translates your Python code to your SQL query, and that is what has happened here. We wrote Python code, but this converted it into a SQL query that got pushed down to BigQuery level and was executed by BigQuery. Okay, so it does a push down processing of your data. So I see that my query has succeeded, and you will notice here that we processed up to 1.8 terabytes of data using a simple notebook with only limited resources. So this is the power of using BigQuery DataFrames. And in time, I see my results are ready. This is what the results look like. I've only selected a few columns from the tables. Now, one thing to note here is you will see an index on every row, right? You'll see an index attached. So this index you're seeing here because BigFrames has provided a value-added feature of ordering. So what it does is, so let's say if you were using Pandas, since Pandas runs in memory, it can leverage in-memory indexes. But in this case, BigFrames actually loaded this information into from a data warehouse, and a data warehouse, if you know, does not inherently have any indexing. So BigFrames has added that additional logic to add indexing to your results. And if you refer to this data frame and if you refer to value at index 0, you will always get the same row. Let's move on to the next step. So until now, what we did is we loaded the data from the two tables, we merged it, and we filtered it. Now, next step, we are going to build a feature set, and my feature set consists of 3 features. The first one is total number of orders. The second one is the return ratio per customer, and I will get to the third one in a second. So when I run this, you will notice that my query succeeded in 0 seconds, and I do not see any output. Do you know why? I will tell you why. Sandeep mentioned earlier that BigFrames does deferred evaluation. So what this means is it is not going to calculate an expression unless and until needed. So in this case, since we have not enforced the calculation, BigFrames is calculating the expression in the background, but it is not executing it, and hence we are not seeing an output. Now, let's switch gears a little bit. So from traditional data aggregation to pre-processing. We all know that pre-processing is a very important step in machine learning to ensure that your model accuracy is good, as well as to prevent any model overfitting. So in this case, we have used a min-max scaler on our sales price, so that because our sales price is a number that can start from 1 and it could range to thousands. And we did not want our k-means model to get affected by outliers. So that is why we have applied this min-max scaler pre-processing function from BigFrames ML package, and we have calculated a sales price, a scaled sales price, so that it falls between 0 to 1. So we calculated 3 features. Now we are going to create a data frame with a combination of 3 features. So at the end, you can expect the result to have user, their gender, along with the 3 things: count of orders, average spend, and return ratio. So our feature set is now ready. Now next step is to train our k-means model. So if you're familiar or if you've used scikit-learn before, you will know that train test split is a function that is a handy tool when it comes to dividing your data between training and test sets. It allows you to ensure that the training of your model happens in an efficient way. So in this case, we have split our training data, and from the BigFrames ML package, we have imported the k-means model. And you will also notice that in k-means, we are setting 2 configurations. We are saying that the number of clusters should be 4. So what this means is k-means will divide our customer data into 4 separate clusters based on their shopping habits. And we have also specified maximum iterations equal to 4. So again, we have done this to show you that you have the ability, you have all the knobs in place to tweak your ML models using BigFrames ML. Now we see that this job is running. Let's see what is happening in the background. The Python code that we had is converted into BigQML SQL query that you're seeing here. And I see that this completed. And here you can see the training loss. You are able to see the training loss, which kind of settles down towards the last iteration. And you're also able to see the iteration information on how much time was spent in every iteration. So let me go back to the demo. So now we have our k-means model ready for prediction. So now in this next step, what we are doing is we are using the predict function and we are giving it the data frame, the feature set that we had earlier. And we wanted to create 4 separate groups for our customers based on their usage pattern. And data itself can be overwhelming. That's why BigFrames supports native visualization capabilities. We support a number of visualizations that include histograms, scatter plot, line graph, and many more. So here what we have done is, you'll be able to see that we created 4 clusters in k-means. You're able to see those 4 clusters on the screen. So looks like cluster number 4 are people who, who love placing a lot of orders, but they do not spend a lot because I'm seeing their average spend is somewhere around 0.2. Whereas we have this green cluster that does not place many orders. They just place 1 order, but they spend like a lot on those orders. And then somewhere, in between, we have cluster number 1 and 3 here, which are like average spenders and are placing average number of orders. So we saw the results of k-mean cluster. Now, the results of k-mean cluster are not very easily understandable to our GenAI model. So let's make it easy for our GenAI model to understand these results. So we have created a cluster summary here where we've said for every cluster, what is the average spend, what is the count of orders per person, and what is the return ratio. Now we will be using this cluster summary. We will be providing it to our GenAI model to generate personalized marketing emails. So let's initialize the model. The session and connection that are used for initializing this model, I already created them in the first step, and looks like our model is now initialized. So, one thing I completely forgot to tell you is that all our customers whose data we are analyzing, they love Taylor Swift. I mean, who doesn't love Taylor Swift, right? So what we are going to do is we are going to push the Gemini model to be creative here, and we are going to ask it for every cluster, give us a clustered persona. Like what is the persona of these customers? What are their interests? What do they think about when they shop? What is a favorite Taylor Swift song for this cluster? Give us a witty email headline because we want to catch our customer's eye as soon as they read our email, see our email, and the email body. So looks like our Gemini model created results, and it says cluster number 1 is the occasional shopper, cluster number 2 is the loyal Lux, cluster number 3 is the practical purchaser, and cluster number 4 is the impulsive buyer. And let's quickly go up a little. So cluster 4, it says, for cluster 4, it has categorized it to be an impulsive buyer. We saw that because they love placing lots and lots of orders. And I think if someone was to plot my shopping habits on a chart, I would be an impulsive buyer. Anyways, so let's see for the interest, it is saying that, the impulsive buyer is emotional and they love, placing a lot of orders. Their favorite Taylor Swift song is Wildest Dreams. And the witty headline is, let your wildest dreams come true. And there is this email that has been generated. So folks, this is the end of my demo. In this demo, we saw the data to AI journey using BigQuery DataFrames and also Gemini model. And wasn't this exciting? We processed terabytes of information using a simple BigQuery notebook. And what is more exciting is our customer Carrefour is using this in practice. So with that, let me pass it on to Guillaume to learn more.
Thank you, Sonakshi. I'm Guillaume Blaquiere. I'm a data architect at Carrefour, and I'm here to talk about the hard work and the nice work done by not my team, by colleagues from Brazil and Belgium. I'm talking on their behalf. It's not my work, and I don't want to steal them. That being said, what's Carrefour? Carrefour is one of the major retailers in Europe and in the world, with dozens of countries, thousands of stores, and millions of customers. And every year, we have more than 3 billion of transactions. That's a huge volume of data, and that's why we are calling that big data, and we'll see why. Our data analytics stacks is this one. In fact, in all our countries, we have the same data domain. We have customer data, we have stores data, we have e-commerce data, and we have our supply chain data with trucks and warehouse. All the countries of Carrefour processing locally their data with data prog, data flow, pub sub, cloud function, whatever. But at the end, the data land in BigQuery. From there, we have a project as a headquarters named United, and we aggregate, standardize all the data in the same data warehouse to have a global overview of the Carrefour business. And at the headquarters, we have also data science team that explore, build, and train model to solve global challenges. Because in the end, we are selling products in store and we are doing the same thing in all our countries. But sometimes it's not enough. Because we have also local data science team that's in charge to solve local challenges, and they have to do the dedicated model and AI training for these local challenges. And I would like to enlighten the work done by the Brazilian and the Belgian team. Let's start with Brazil. In Brazil, the use case is to avoid the shortage in store. That's why the team need to process the stocks in store and in the warehouse, the order done by the store and the warehouse, the sales done in the stores the past days, the past weeks, to forecast the next sales, the sales is in the next days and next week, to forecast the stocks needed in store to avoid shortage in store. For that, the team need to process hundreds of petabytes every week. The team, a Python-friendly team that are very great in Python, use Pandas DataFrame, but because we have a lot of data in Brazil, it does not work. The team envisioned to use Spark, and of course PySpark, to distribute the computing across multiple nodes to be able to process efficiently the data. But it was a new framework to learn. It was also distributed computing, and sometimes it's difficult to process the data in a distributed way, and is not very good as design. And BigQuery DataFrame has been a game changer for that. Now they continue to use Pandas DataFrame, and they use BigQuery DataFrame to distribute the processing over BigQuery with the slots of BigQuery, and continue to use their Python and their code in Python because they love Python. Today, in production on Composer and Airflow, they can process hundreds of petabytes of data every week and avoid shortage in store. And they are also starting to build reusable components for other projects and other teams, again, to process the stocks and the sales in the future. Now let's move on to the Belgian team. This time is different. We have a data engineer team that need to process, to transform, to merge, to join a large volume of data, but also of tables. They started to do that with Vertex AI notebook, and the default instance was too small. They increased the size of the instance, and it was still too small because we have many data at Carrefour. And in fact, they started to think to write a huge query in BigQuery to perform this processing. The problem is, if you have the ability to read queries written by someone else, it's difficult to understand, it's hard to improve, it's impossible to debug, so it's not the right way to do that. And BigQuery DataFrame here again has been a game changer because the team can now use again a procedural language, only some piece of code with BigQuery DataFrame. The code is easy to read, easy to understand, easy to debug, easy to improve. And they can use also a smallest Vertex AI notebook. And now the data science team is happy because they can have their KPIs every day. It works very well. In the data engineer team, Romain shared with us a quote that's here. With BigQuery DataFrame, we can now easily and quickly process a large volume of data without worrying about the hardware capability. And indeed, it's very important because you don't have to pay a lot to process your data. BigQuery does that very well for you. And the volume is no longer an issue for you also. So thank you, Romain. Thank you for your attention. And I give the floor back to Sandeep for the conclusion. Thank you.
So much. Can you guys hear me? All right. Thank you so much. Live demo is always the best, and followed by a customer speaker. I can't ask for more. All right. If this got you interested, and some of you got some of you excited, there are resources to follow. If you go to our BigQuery Studio today, you will find a demo notebook, a Colab Enterprise notebook. Click on that. In 3 minutes, you will get a taste of what BigQuery DataFrames is. Right? And if you're interested in learning more, there are a few other sessions that you can go to. They are listed here. You're always hungry for feedback. So whatever you thought about our session, we really appreciate getting into your next app and giving us feedback about the session. All right, I think that's it. I'm getting a cue here. Thank you. Goodbye.